still get into differential equations when we move this class, right, Brett?
I don't know.
There's, I don't know what the chances look like.
Okay, how about number 2? So what I think really helps you in this kind of stuff is the notation. Use notation that these math people like. Right? Remember seeing this kind of thing? Right? Inside the parentheses, you put in what is the derivative of cosine theta. Cosine theta. You take the derivative of cosine theta, and you get sine theta.
Now that's negative cosine theta, right?
If you put negative cosine, and test it, always test it. If you put negative cosine theta, take the derivative of negative cosine theta, what do you get?
Sine theta.
You get sine theta times a negative 1. And that's what you want. So it would be negative cosine theta, right? So if it was just cosine theta, take the derivative of it and always test it out. I think Brad and I were talking about this and we screwed it up. Take the derivative of this, you get negative sine theta. So that means that now you got to throw in a negative sign in here. Whether you throw it in here or outside, it works. Okay. Now you have to evaluate it. Cosine of pi is what? Negative 1. Now, let's see if we had a review of the unit circle. We don't. Okay, we better do that. Right? See if you remember this unit circle. But let's just write down the answers first. So it's a negative, negative 1, and then what do?
You go subtract.
Subtract the cosine of
0.
0, which is,
Well, plus, right?
it's plus 1. So a negative 1 is a negative 2, times a negative 1. Make sense?
I see. You can make all the way up. So
Yeah.
when it goes
You could have it on the inside, it's fine. But it's cleaner, I think, if you have it on the outside, because you take one minus the other. It's easier to see. So let's see if you remember this unit circle stuff. If you don't, that's why you're having, let's see, draw something like this, right? It's just a circle with what radius? 1. Okay. So this is 1. And this is really how you're converting degrees to radians. Right? Yeah, let's say you picked. Oh, let's finish this unit circle thing here. Yeah, so this is either 1 or it's 2 pi. Where is 0? Why is this so thick? Where is 0?
that could be there too, right?
Now, what is the 0 thing? 0 is when they're talking about the degrees, right? So let's just jump back and do some of these. Like 2 pi, they never say radians. Radians is unitless. 2 pi radians is how many degrees? 360. Or it's also 0 degrees, right? Because you haven't even moved. Or it's 720 degrees. Or it's 1080 degrees, right? So 2 pi radians. How about pi radians? That'd be how many degrees? 180. Okay, so now we're talking about degrees. We're talking about this thing, right? Right? That angle. So that angle can be in terms of degrees or it can be in terms of radians, right? So this distance, well, let's just go up to straight to the top. That might make it easier. Let's make it green. Go up to the very top. That theta is how many degrees? 90 degrees. That theta, that angle, is also how many radians? Pi over 2, a half pi. Yeah. So if you can see that, this is good, right? So that's pi over 2 radians. This is pi radians. Or you could call it 180 degrees, right? 3 pi over 2. Now, the reason why this is nice is because the cosine, let's clean this up a little bit. Why can't you erase? Oh, I know why. The cosine is, right, this arc length, right, of the adjacent side. So, for example, if you have, let's make it red. If you had this angle, here's my cosine. It's just the length, right, of that adjacent side. Here's my sine. It's just the length of that adjacent side. So the reason why you want to know this unit circle is so you can make quick answers. For example, if I said, what is the cosine of 180 degrees, you would say that length is going to be what? Cosine of 180 degrees, right? That theta is going to be way over here. It's going to be -1, right? What's the cosine of pi over 2? You could also say 90 degrees, but without doing it on the calculator, the unit circle, get used to it, it makes your life so much easier. What's the length of the adjacent side if the arrow is just pointing straight up? The x length, the length on the x-axis. There isn't any, is there? There's no x component at all. It's all in the y component. It's going straight up. So your entire length is just on the y-axis. So it's 0. But the sine of pi over 2 would be what? 1. Because now, because remember, the sine is the y side, and it's getting bigger and bigger and bigger as the theta gets bigger until it finally maxes out at 1. And then it's going to get smaller and smaller and smaller. Okay? But it's always going to be positive, the sine is. Over here in this quadrant, the cosine is always going to be positive or negative. It's always going to be negative, right? And then as the angle gets bigger and bigger and bigger, yeah, it's going to get more and more negative until it maxes out at 1. Right? Let's just do a few more tests to see if you're following here. How about the sine of 3 pi over 2? What would be the sine of 3 pi over 2? This would be the y side, the y component. If you're at 3 pi over 2, it's just -1, right? Because there is no x component. It's all y component. It's going straight down. It's all y component. So if you had anything else, the cosine of 5 pi over 2, those you just do on your calculator. I don't have all those memorized, right? That's a bad example of pi. That's 5 pi over 2. You could figure out 5 pi over 2. This is pi over 2, pi, 3 pi over 2, 4. It's just pi over 2. That's not a bad example. Cosine of, I don't know, 120 pi over 7. There you go. Can't do that one in your head. You do that on the calculator, and that's what's coming up. Okay, but it's going to be really helpful to be familiar with the unit circle. Being able to say that the cosine of 0 is, now again, this isn't quite, you should have a degree sign. Cosine of 0 degrees is?
What, cosine of 0 degrees?
Yeah.
Oh,
1. Well, oh, hey, Annabelle, come on in. You can listen to this. It's good for you.
Oh, I thought you were having
Yeah. It's PChem. We're reviewing the unit circle.
You know what really helps me is like just driving or drawing the sine wave and the cosine wave. Like I don't even really use that much. I usually just use the wave, you know, starting at 0 with sine and just, you know. And then
Oh, yeah.
I don't know. It always seemed a lot easier for me.
Yeah, 0, 1. So
It's nice to
this,
see it on
okay,
you, though.
hang on. This is a good one. Is this a sine function or a cosine function? Right? Now I should label this stuff. This is my y-axis. This is my x-axis. Pick a point that's easy, like the origin, the 0 here. Whatever it is, at 0 has to be 0. Is that the sine or the cosine? Right? The y value sine of 0 is 0, right? Sine of 0 is 0. Right? This would be, that'd be the sine function, because the sine of 0 degrees is 0, right? Because this is 0 degrees, and there's no y component. So like, yeah, the cosine would be this one. Start here. All right. Yeah, start here. No, that's only half off. Down there. Yeah, I don't want to screw this up. Okay, but that's the idea. All right? So whenever you see the integral from 0 to pi of sine theta, work it out, but it's always going to have to be positive 2. And you're going to see it a lot, so that's why the word memorize is up there. So you have to work it out all the time. 0 to 2 pi of d phi, that's called phi. Okay. So that's what, again, use the notation. So even though these aren't that complicated of problems, use the notation because it keeps you from screwing up. What do you put inside the parentheses? Richie, what do you put inside the parentheses?
Just think of no.
Yeah, well, phi, technically phi.
A fee.
Yeah. Right? Because the derivative of phi would be 1.
So then you have 2x minus
2 pi.
sigma.
2 pi.
Is that sigma or 0?
It's radians. You're going a complete evolution. So phi is going, starting out at 0, going all the way to 2 pi, one complete revolution on the unit circle. So whatever phi is, it's just a replacement of, I think, z. They're replacing x, y, and z with spherical coordinates. They're called spherical polar coordinates, is where this is coming from. But we're not quite there yet. So the derivative of what gives you 1, phi does, and then you put in 2 pi and 0. The answer is just 2 pi then, right? So how many radians are in 360 degrees? 2 pi. The cosine of 69 degrees is, this is just making, if you do this on your, you have your calculator, you want to do this because then I know that everyone's calculator is in degrees.
Are we going to be able to check out the calculator?
Yeah. So do this to make sure your calculator is in degrees. You should get 0.358. So that's the purpose of this question being there. Now everyone's calculator is in degrees.
0.358.
Yep. Convert 90 degrees to radians. How many radians would that be? You can either calculate it or remember the unit circle. Maybe pi over 2. Right? 90 degrees would be pi over 2. And if you don't remember it, you could always calculate it. What I mean by calculating it, you have 90 degrees So just multiply it by something that you know. Yeah, there's 2 pi radians in 360 degrees. So you end up with pi over 2. Okay. You pretty much have to do it this way when it's not one of those simple parts of the unit circle. 180 degrees radians would be pi. 0 degrees radians. Not 0. You have 0 degrees. Radians is the length of the x component on the unit circle. So if you're at 0 degrees, that's at go back to the unit circle.
I thought it would be 0.
Well, it gets. Okay, let's go back to your answer. What was the question? 0 degrees, right? Cosine of 0 degrees. So it's either the best answer is technically 1, 2 pi, 4 pi, 6 pi, 8 pi. Now, you could answer the answer 0 would come in if you introduce a physical problem, where because you're talking about revolution, you're talking about distance. So if the whole thing hasn't even started moving yet, then nothing would have moved. So it hasn't moved 0 degrees. So yeah. So but what this is really talking about is cyclic motion, just going up and down, and it's going the fastest in the middle. So that's really all this is really talking about. Okay, let's just wrap this, do these, and then we'll call it.
So we're saying that converts 0 degrees to radians, that is going to be 2.
It would make the most sense to me. Or I guess you could, yeah, you could say 0. I guess you could argue for 0. You could say it hasn't even started out. So it's at 0 degrees, which is the same as 360 degrees on the unit circle, right? So you could argue that. I can't say you're wrong, right? And then 1 revolution, 2 pi, 4 pi, 6 pi. I think all those would work. That fits. Yeah, I'm glad you mentioned that, because that makes more sense, right? So find a value for each. The cosine of pi is -1. You can always do it on your calculator, but if you do it on your calculator, you got to switch to radians, right? So make sure you know how to do that. On these, I have to go to mode 5 dot or something. But I noticed that it says DEG up on the upper corner right now. So if I go to, where's my mode? 5. Yeah, if I follow the little notation up on top, it switches over to RAD. And then I plug in my pi, shift pi, take the cosine of it. Yeah, you get -1. So make sure you can play around with that on the calculator, because life is going to get uglier than that. The cosine of 0. 1. Cosine of 2 pi. 1. Right? Okay, so we'll mess with this some more next class period. Fun.
And you said check will work best for the reference, right?
Yeah, for that, yeah. Then I can just give it right back to you.
And you said,
You can cash, I'll take cash, but
and you said
check seems more secure.
we will be doing lab on this week,
Wednesday. Yeah.
2:30. Don't be a minute late.
Yeah, don't be a minute late.